You think China just caught a rocket? That is the headline. But it is not the business story. The real story is this. China may have found a different way to attack the most expensive problem in the space economy, not how to reach orbit once, but how to reach orbit again and again and again without burning a fortune every time. Because in space, the rocket is only the visible part. The invisible part is the cost curve. Every satellite internet network, every Earth observation company, every direct-to-phone service, every military communication system, every weather satellite business, and every future lunar supply chain depends on the same boring question. How much does it cost to put hardware above Earth? If that cost stays high, space remains a trophy. If that cost falls, space becomes infrastructure. That is why this rocket catch matters. On July 10, 2026, China launched the Long March 10B from the Hainan Commercial Space Launch Site. The rocket delivered a satellite into orbit. Then, roughly 6 minutes after launch, the first stage booster came back and was captured by a giant net on a sea-based recovery platform. No landing legs, no Falcon 9-style touchdown, no booster standing upright on a drone ship. Just a massive machine falling back from the edge of space, 4 hooks, a waiting ship, and a net big enough to turn a falling rocket into a recoverable asset. At first, this sounds like a cleaner, quieter version of what SpaceX already made famous. But that is the wrong way to look at it. SpaceX asked one question: can the rocket land itself? China's net recovery asks a different question. Does the rocket need to carry the entire burden of landing? That difference sounds small, but in aerospace, small differences become business models. A Falcon 9 booster has to do almost everything itself. It has to survive re-entry, guide itself down, restart engines, control attitude, manage fuel, deploy landing legs, and touch down with terrifying precision. That is why SpaceX's achievement is so valuable. It did not just land a rocket once, it turned landing into routine. By 2026, SpaceX had passed more than 600 successful booster landings. One Falcon 9 booster had flown for a 36th time. That is not just engineering. That is operating history. That is data. That is customer confidence. That is a launch company becoming a transportation network. China is nowhere near that level of routine yet, and that is exactly why the Long March 10B recovery is interesting. It is not proof that China has caught SpaceX. It is proof that China is trying to build a different path into the same business. Here is the part most people miss. Reusable rockets are not really about rockets coming back. They are about what comes back in usable condition. A booster that returns damaged is a trophy. A booster that returns, gets inspected, repaired quickly, and flies again at lower cost is a business model. That is the brutal line between a viral video and an industrial breakthrough. This is where China's net system becomes more than a strange visual. Landing legs are not free. They add mass. They add mechanisms. They add failure points. And in launch economics, mass is not just mass. Mass is money. Every kilogram used for recovery hardware is a kilogram that cannot be sold as payload, fuel margin, or performance. So China's idea is not simply catch the rocket with a net because it looks different. The idea is to move part of the landing problem away from the booster and into the recovery infrastructure. The rocket still has to do the hard parts. It still has to survive separation, re-entry, high-speed airflow, heating, vibration, guidance, and descent. But the final few seconds, the moment when a Falcon-style booster must balance itself on fire, are partly handed to the ship, the net, the hooks, and the hydraulic system. The difficulty does not disappear. It moves. And when difficulty moves, cost moves with it. That is the real business question. Is it cheaper to put more complexity into every rocket, or to put more complexity into a reusable recovery platform? SpaceX chose one answer. China is testing another. Neither answer is magic. A sea-based net system has its own problems. The ship has to be in the right place. The sea has to cooperate. The net has to absorb massive forces. The hooks have to connect. The platform has to reset. The booster must not be damaged beyond economic repair. And the whole system has to work not once, but repeatedly. That last word is everything. Repeatedly. Because one successful catch does not change the space economy. A repeated catch might. But there is a second layer to this story. and it is even more important. China is not only testing one reusable rocket path, it is building a portfolio of paths. The state-backed Long March 10B is one path. Private companies are trying others. Landspace's Zhuke-3, for example, took a very different approach. Stainless steel structure, methane liquid oxygen engines, and a more conventional vertical landing concept. In December 2025, Zhuke-3 reached orbit on its first flight, but the booster recovery failed after an abnormal combustion event during descent. For a casual viewer, that is failure. For an aerospace company, it is also data. The rocket reached orbit. The recovery system was exposed to real flight conditions. Engineers got information about structure, re-entry, guidance, engine behavior, thermal protection, vibration, and failure modes that no computer simulation can fully replace. That is why the phrase failed test can be misleading in aerospace. A bad test that produces good data can still move the industry forward. This is the business logic behind China's multi-route strategy. One route tests kerosene engines and net recovery. Another tests methane engines and landing legs. Another may test different materials, different landing systems, different launch sites, or different levels of reusability. Some will fail, they have to. Reusable rockets are not created by press releases. They are created by broken hardware, telemetry logs, redesigns, and another launch. That is not glamorous, but it is how an industrial base learns. And for China, this matters because the real target is not one rocket. The real target is launch capacity. Look at what SpaceX built around Falcon 9. The rocket is only one part of the machine. The real machine is the loop. Build, launch, land, inspect, refly, repeat. That loop feeds Starlink. By mid-2026, SpaceX had launched more than 12,000 Starlink satellites, with nearly 11,000 still operating. That is not just a satellite project. That is a manufacturing, launch, recovery, and network deployment machine. This is the uncomfortable lesson for every country trying to build a satellite internet system. A constellation is not built in PowerPoint. It is built on launch cadence. You can announce 10,000 satellites. You can draw beautiful orbital maps. You can reserve spectrum. You can describe global coverage. But if you cannot physically launch satellites fast enough, the constellation remains a spreadsheet. And orbit does not wait forever. International satellite filings have deadlines. Frequencies and orbital resources must be brought into use within a defined period. In the current ITU framework, that period is 7 years. That means the space economy has a clock. If you cannot launch, you do not just lose time, you risk losing position. This is why reusable rockets are not only a technology race, they are a real estate race in orbit. The best orbital shells, the best service windows, the best coverage patterns, the best commercial relationships, all of them depend on getting hardware into space at scale. And scale depends on cost. That is the part normal viewers rarely see. A rocket launch is a spectacle, but a launch business is a logistics company. It has suppliers, it has factories, it has engines, it has tanks, it has fuel, it has launch pads, it has ships, it has inspection crews, it has insurance, it has customers waiting for payload slots, it has regulators, it has weather delays, it has turnaround time. A reusable rocket is not one machine. It is a supply chain that flies. This is why the Long March 10B catch is more important than the image itself. The image says, China caught a rocket. The business question says, can China turn this into a repeatable launch system? Can the recovered booster be inspected quickly? Can it fly again before the end of the year? Can the recovery ship handle repeated operations? Can the net catch avoid hidden damage? Can the system work when the sea is rough, when wind changes, when schedule pressure increases, when customers are waiting, when satellites need to be launched on time? That is where the real test begins. Not at the moment of the catch. After the catch, because the value of a reusable rocket is not decided when it lands. It is decided when someone calculates the next launch. How much inspection? How much refurbishment? How many workers? How many days? How much risk? How much payload? How much cheaper than building a new booster? That is the spreadsheet that decides whether this becomes history or just a headline. And this is also where SpaceX still has the advantage. It has years of booster recovery data. It has high launch frequency. It has operational discipline. It has customers. It has Starlink creating internal demand. It has a feedback loop most competitors do not yet have. China's advantage is different. China has scale, state-backed demand, private companies willing to fail, satellite constellation ambitions, and an industrial ecosystem that can test multiple routes at the same time. One side has deep operational experience. The other side is building optionality. That is the real competition. Not rocket versus rocket, system versus system. And that is why the net catch matters. It gives China one more possible architecture for lowering launch costs. Not the only architecture. Not necessarily the winning architecture, but a real one. If it works repeatedly, it could change the economics of certain missions. If it lowers booster side mass, it may improve payload margin. If it reduces the precision burden of final touchdown, it may make recovery easier for some vehicle designs. If the ship becomes part of the reusable system, then the rocket is no longer just a rocket. It is one component in a larger recovery network. That is a very factory logic kind of story. The value is not in the object. The value is in the system around the object. A cold chain company does not make money because it owns refrigerators. It makes money because it controls temperature, time, spoilage, logistics, and reliability. A shipping company does not make money because it owns ships. It makes money because it controls routes, schedules, ports, containers, and capacity. A reusable launch company does not win because it lands one booster. It wins when it controls cost, cadence, recovery, refurbishment, and customer access to orbit. That is the real lesson here. China caught a rocket, but the rocket is not the prize. The prize is the ability to make orbit cheaper, more frequent, and more industrial. Because the next space economy will not be built by the country that makes the loudest launch video. It will be built by the system that can move hardware into orbit like cargo. Again, and again, and again. And when that happens, space stops being a stage for national pride. It becomes infrastructure. Satellite internet becomes cheaper. Earth observation becomes more frequent. Disaster monitoring becomes faster. Navigation improves. Remote industries connect. Data services expand. Military awareness increases. And the companies that own the launch loop gain power over everything built on top of it. So the next time you see a rocket booster falling back to Earth, do not only ask whether it lands, ask what it costs. Ask how fast it can fly again. Ask how much payload it saved. Ask whether the data improves the next mission. Ask whether one successful recovery can become 1,000 routine operations. Because the future of space will not be decided by the most dramatic landing shot. It will be decided by the most boring numbers: cost per launch, turnaround time, payload capacity, failure rate, refurbishment cost, launch frequency. That is where the real money is. And that is why China catching a rocket in a giant net may be much bigger than it looked. Not because it proves victory, but because it shows a new industrial path is being tested. The most important moment in the space business is not always the launch. Sometimes it is what comes back. And sometimes the future is not decided by who reaches space first. It is decided by who can afford to go back again.